Sweet. I'm Akash, co-founder and CEO of Dognosis, and I'll just speak a bit about how we think we can let dogs teach AI how to smell and why that's interesting. So dogs remain the top dog in olfaction. They're seeing a world of scent in parts per trillion. Our best machines see parts per million. So you can compare the dog's world of scent as 4K ultra high definition. Our best machines see 8 individual pixels. That's why we still depend on dogs, militaries around the world, on what they do in the battlefield. Now, it's not just explosives that have sense. We know breath as well contains sense from these cocktail of volatile organic compounds or VOCs. And we know that different diseases change this cocktail in a specific way that is consistent across individuals. And what we also know is that with a good sensor, the right algorithm, and enough compute, we can actually accurately identify the scent of disease in breath. On the left is one of the best sensors, the mammalian olfactory bulb. And that's what dogs do. So they're able to pick up scents. On the left is a photo from an organization in the UK, Medical Detection Dogs. They've been doing this for the last 2 decades. On the right is one of our dogs at Dognosis. And the dogs are really good. So for multiple diseases, including different types of cancers, COVID, animal diseases, neurodegenerative disorders. There's a Guinness World Record actually for the number of diseases detected by a disease detection organization. It's 28. And the accuracies are consistently above 90% for the studies that did it well. The challenge though is the humans. So we kind of get in the way. We need the dogs to communicate to us because we're another species. So they need to be trained to specially respond. This takes a lot of time, 12 to 15 months, causes chances of error and bias. It's not really the dog's ability to pick up the scent, it's their ability to communicate it to us that is hard to scale. So what we said is, let's teach the machines to read the dogs instead of depending on us humans with all our flaws. So we combine data from a wearable BCI, so that's fully non-invasive, records EEG, so brain waves. We have other types of sensor, respiration, heart rate, as well as computer vision to take canine compute and translate it into digital bits. And this is kind of what it looks like. So this is the infamous video that is happily playing. And this is Whiskey in all her glory, who's sniffing a face mask in each one of those sports. The ones in greens are from control participants. The red one is from someone who had been diagnosed with some type of cancer. And Whiskey makes a decision there. I've smelled cancer. I'm going back to get my reward. I expect, my treats. While she's doing that, we have, this is Cheetah here, who's wearing our EEG helmet. We have the computer vision from different camera POVs. This is one of them. Also that harness that's measuring. And so each decision now is being quantified by a machine learning model that can tell us, okay, is this the scent that we think Cheetah is sniffing based on all the past instances of what her decision making was. And you can see her now do it again. It's just half a second really that she takes to make a decision. And she's like, okay, I sniffed it, give me a reward. So the idea is that this allows us actually to scale what the dogs do because software can automate what is otherwise a time-intensive process. And so the product we're developing is Breathe Easy. People breathe into a face mask, seal it in a bag, ship it over, stays stable for up to 3 months at a time at room temperature, and then a team of dogs evaluates the sample. And what we've done in the last year and a half is do a large clinical trial in India. So we had 1,500 samples after collecting 6,500 unique breath samples. And at stage 1, the dog's ability to pick up multiple types of cancers was 87%. The next best thing was 17%, which is by a company called Grail that is worth about $6 billion. So the dogs are already way better than what is currently on the market, and this is for 30 different cancer types. What we're doing next year is launching with Indian state governments and healthcare providers, test 25,000 people by March 2027 in the real world and really check what the dogs can do in real world settings. And just before I end, I want to talk a bit about a longer term vision, which is what we think this system and this data flywheel will allow us to do is basically get the ground truth for these cocktail of molecules. So what the dogs perceive and that perceptual representation is not the same thing as what's in the molecules. The molecules encode sense in a non-linear combinatorial fashion. If the dogs are giving us these perceptual labels, we can actually then, we think, reverse engineer something we're calling reinforcement learning by canine feedback. to actually train AI to smell. And the reason we think this is interesting is, as I said, a lot of diseases have sense, and olfaction is actually a really good first layer because you can do it passively in real time, and it seems to have really high sensitivity. What's also interesting is that in the neuroscience literature, people have argued how olfaction, being the oldest sense, is what all the other sensory systems kind of built on top of, and also what intentionality and agency in biology comes from. And our AIs don't have that, and people are wondering, like, how do we get agency into AI systems? Maybe we go back to like the earliest sense and what biological intelligence built off of.
So it wasn't quite clear to me if there are multiple positives in a sample or just only one.
So it's only one type of cancer. Usually, sometimes it had spread, and so it is multiple types. But the idea is the dogs are rather unique in that they seem to be able to generalize a common scent of cancer. So wherever in the body cancer is, the metabolism is giving off these byproducts that have a consistent signature. You can also specifically train them to identify a specific cancer, which is what we're doing now. So we have the generalist dogs who can generalize across different types of cancers, and then a specialist dog. And so you can kind of run it through first the generalist and then the specialist to know where in the body the cancer is. But all of them right now can actually identify different types of cancers.
That wasn't actually my question. If there are multiple positives in a set of 8 or something, can the dog trigger multiples?
Oh yeah, the first time they see a positive, they'll go back expecting a reward, and then you shuffle the samples based on what they've already sniffed.
So you process the same sample through multiple times?
3 dogs see each sample once.
Okay,
Yeah.
If somebody has, let's say, skin cancer that is local and you're using a breath mask to collect things, does that still show up?
I think skin cancer is one of the few cancers at stage 1 which probably you can't detect from breath. We didn't have any stage 1 skin cancers in our cohort. It's not very common in India, but I would guess that that is one of the few ones that has no trace in breath. Yeah.